So let's start the limit fits and tolerances and why we study. First of all, we need to know this limit fits and tolerances. So we study, and the importance is that because since the in the manufacturing, most of the products are produced in huge lot, and in huge lot, suppose a random product has to be picked. Now, if we are picking up that random product, so that should be within some tolerance so as to maintain the interchangeability between the assembly which is being used for that product. So this is the reason why we generally study limit fits and tolerance, and there is always some kind of tolerance within which the products are produced in manufacturing process. Always when a production happens, so when a production happens, at that time there are many factors which affect the production process. Suppose temperature, tool wear, vibration, deflection, and so on. So like that, many factors are there which affect the manufacturing process in many ways, and therefore the dimension in products also vary to a large extent. However, the dimension always should be in a particular limit so that interchangeability in between the parts are maintained, and if randomly a product is picked up, so it should meet the desired its role. So before starting this limit and fit and tolerances, we need to study some of the basic terms. So first term is the shaft. So what is shaft? So shaft in generally represent the diameter of any external dimension of a component. So suppose if we write this as a shaft, then generally we are talking about the external dimension. So it is not only a diameter of a circular shaft, but also to represent any external dimension of a component. And if we write this is as a whole, suppose this is whole, then whole not only represents the circular whole, but also it represents the internal dimension of a component. For an example, if we are considering the hub, then hub in that whole, that will represent the internal dimension of that whole. Now talking about the basic size. What is basic size? So first we read shaft, second is hole, third is basic size. So basic size is the nominal size also we call it, and it is it will remain same. So it is nominal size and it will be same for both hole and shaft. It is also the actual size which is decided after calculating the strength. So next is the actual size. What is actual size? So actual size is the size of product produced in manufacturing. So it is the actual size. Now next comes the limit of size. So there will always be some limit which will define for a particular product. So there will be a maximum limit and there will be a minimum limit for a particular product or component. So if we talk for this whole, then this is the maximum limit. So this is the maximum limit and this will be the minimum limit. This will write as minimum limit. We also call this as high and this as low limit. In this case, so this is the maximum limit, and the other one, that is the smaller one, will define as the low limit. So this is the low limit of this shaft. So next important terms is tolerance. So what is tolerance? If we call what is tolerance, then this is the difference between maximum or high size minus minimum or low size for that component. So this is the tolerance. Next very important term is the allowance. So next important term is the 7, the allowance. So what is allowance? Allowance is the max difference between the maximum material limit of the mating parts. So what does it mean? So first we write it is the maximum material limit difference in mating parts. So we always need to remember maximum material limit in case of shaft will be its high limit, and in case of the hole this will be the low limit. So in the case of shaft, the maximum material will be corresponding to the maximum size or high size generally we call. So this is the maximum material condition for a shaft, and for a hole this will be the maximum material condition. So what will be the value of allowance? So we can determine the value of allowance as, so it is the basically difference between maximum material limit. So this is the value of allowance. This is the difference between maximum material condition for a shaft and for a hole. Now allowance can be positive or negative. So if the size of shaft, so allowance can be positive or negative. So if hole size is greater than shaft size, then our allowance will be positive. Whereas if the reverse is there, then it will be negative. Now next terminology which comes in the limit fit and tolerances is the deviation. So deviation. So what is deviation? So deviation is the algebraic difference between a size and the corresponding basic size. So suppose this is the zero line or basic line. Now what will be the difference? Suppose whether it is a shaft or a hole, then we'll calculate the difference in its size and this will represent the deviation. So there can be two types of deviation. So first is the upper deviation and the second is lower deviation. So what is upper deviation? So this will be the difference between the maximum limit of the size. So in this case, this is the maximum limit. So what the difference between the maximum limit and the basic line will give the upper deviation. So let's write this. This is the upper deviation. Now we need to remember this thing. Suppose the upper deviation or whatever be the maximum limit is there, and if it is below or the size is less than the basic line, then this will be the negative. So in this case, this is the maximum limit and this is the minimum limit. In this case, this is the maximum limit and this is the minimum limit. Now, if we calculate this uh, difference of maximum limit and basic limit or the basic size, then if it is the maximum size is less than the basic size, as in this case, then in this case, the upper deviation will be negative. Whereas in the case of the first one, the maximum limit is greater than the basic size. Therefore, in this case, the upper deviation will be positive. Similar is the lower deviation. Whatever be the difference between the lower limit, so this is low limit, and the difference between the low limit and the basic line. So low limit minus basic size will give the lower deviation. It will be positive if lower limit is greater than the if lower limit is greater than the basic size, whereas it will be negative in case the low limit is less than the basic size. So this is all about the deviation, one important term. Now next is the zero line or basic line. So I told that at this particular line the deviation will be zero, and it is a line of zero deviation. So at this line deviation will be zero, and this is also the basic line or the nominal size which represent the design condition for a particular product. Now the next important term is the fundamental deviation. So what is fundamental deviation? So fundamental deviation is defined as the nearest dimension from the basic line. For an example, in this is the low limit and it is the closest to the basic line, then this will be called as the fundamental deviation. So in this first case, this lower limit is the fundamental dimension. However, if we see in this case, the nearest dimension is the maximum limit. So this will represent the fundamental dimension because the maximum limit in this case is the maximum limit. So we have seen the deviation. So deviation is the how much there is a deviation from the basic size. It can be maximum or minimum, and it is defined for both hole or shaft. It can be above to the zero line, that is the basic line, both for shaft and hole, and it can be the below from the basic size. So it can be positive or negative depending upon the relative size difference from the basic or nominal size. So it's all about the fundamental deviation. Now next comes the tolerance zone. So what is tolerance zone? We have to define the next tolerance zone. So tolerance zone is the difference between the two sizes, that is the maximum size and minimum size. So in this case, if we take, so this is the tolerance zone. So tolerance zone is defined by two things. Uh, Number one, it is defined by the magnitude, and other is its relative position to zero line. So magnitude will be the exactly difference between the two sizes. So this is the maximum size and this is the minimum size. So this will be the tolerance in this case, and this will represent the tolerance in this case. Now, since this tolerance is over and above the basic size. So if basic size is, suppose we take x, then this tolerance will be x plus some value will be the tolerance zone. Whereas in this case, if in this case basic size is x, then this tolerance will be negative some value, as it is on the negative side of the basic or zero line. Further to this, there are two kind of uh, limits possible based on this tolerance zone. So there are possibilities of two kinds of limits. So one is unilateral limit and the other is bilateral limit. So these two types of limits are possible. Now, what is the meaning of this unilateral limit and what is the meaning of bilateral limit? If both the limits, suppose this is the maximum limit and this is the minimum limit, if both the limits are on the same sides, whether positive or negative, that is this is the basic size or zero line. So in this case, this is the maximum and this is the minimum. Since both the limits, that is the sorry, the limit, whether the that is the both the limits or the tolerance zone is entirely positive, or in this case it is negative, that is in it is both the limits are entirely positive direction and it is in the entirely in the negative direction, then it is called as the unilateral limit. However, if we represent this as a zero line, so if it is a zero line and suppose this is the maximum limit and this is the minimum limit, so uh, we can visualize that the maximum limit is on the one side whereas minimum limit is on the one other side. It means that therefore this basics the tolerance zone is on the either side of the basic line, so it will be maximum limit some plus value and minimum limit will be some minus value from the basic side. So this is called the bilateral limit. So the case of unilateral limit, and entirely tolerance zone is on the either side, whether it is on the positive side and whether it is on the negative side. Whereas in the case of this bilateral limit, the maximum and the minimum limits are on the either side of the basic or zero rule. So this is the basic fundamental terms and definitions in the limit, fit and tolerances that we need to remember.